Hey, welcome everyone. Welcome back to another edition of our Sipping and Ground Coffee live streams. My name's Dan Painter, and I'm going to be hosting today's broadcast along with the great team here of Renee, Eric, and Chelsea. They keep this thing rolling smoothly for us. Hey, couple things before we get started. Hit the like button on our social media pages. Certainly subscribe to this YouTube channel. If you hit that little bell, that notification bell, what you're going to do is you're going to get up notifications every time we're going to do one of these live broadcasts. So make sure you hit that bell. The other thing, as we go through these broadcasts, please don't be bashful or embarrassed to ask questions as we go. So if there's any questions that come up as we go through today's presentation, again, don't be bashful to ask. And then I think the last thing before we do get started is we're putting out code words for each of these presentations, including today. And so when I give you the code word, the whole idea here is that if you write that code word down and then email it. Mike's not on? Are we doing all right?
You do all right. Both of them are on, so we're trying to take care of a little bit of an echo here.
Okay. Email that code word into marketing@flintandwalling.com. Again, that's marketing@flintandwalling.com. I think if you email like 3 of these code words in for like three different sessions, there's going to be some kind of I think Flint and Walling is going to provide some kind of a small gift in return for sitting in on these. So anyway, today, when we talk about submersible pumps, all right, that's what we're going to be talking about today, and that's a common word used in the industry. It's been around a long time. However, if we want to look at it from a more technical standpoint, we could really look at a submersible pump in a more technical way as a submersible pump and motor assembly. All right, 2 components, 2 entirely different components that are married together to become a submersible pump and motor assembly. So today what we're going to do is we're going to look at the submersible pump, the pump inside of the submersible pump and motor assembly. So a couple things then before we go through these pumps. And we're going to go down through from the top to the bottom, and a couple of reasons for this. You know, this industry for the last probably 2 decades or more, we just basically field scrap anything that goes bad, right? The notion of repairing pumps is kind of long gone. Daddy and Granddaddy used to do that, but today, with the cost of labor, the cost of the replacement components, basically we field scrap everything. And that's okay. And that's been going on for a long time. However, if there's a disadvantage to that practice, and I believe there is one, that is that a contractor, a professional contractor, could probably lose touch as to how these submersible pumps are constructed, what the components are on the inside, maybe even what they're constructed out of or the purpose they serve. There's a disconnect there. If you're not going into a submersible pump, how are you going to know? And so what we're going to do today is we're going to go through a submersible pump. You know, if I walked into a big box store or a department store, I don't expect anybody in there to be very knowledgeable when it comes to pumps, and they all sell these things. And you know, but as a professional contractor, I think we ought to be in a position to be able to answer questions. And so as we go through this pump today, I'm going to point out the components that make up a Flint and Walling submersible. And I'm also going to make a handful of comparisons to the industry, which might come across as a little salesy, I don't know. But you know what? I think most of you can separate fact from fiction. So after I'm done sharing some of this information, that will be the challenge for you is, you know, did I feed you fact or did I feed you fiction? And so anyway, that said, we're going to start at the very, very top of the pump up here, what we call the discharge, all right?
We have a question for you here.
We got a question already. Okay, what's that question?
Someone said, sorry I'm late. Did it miss the password or did I? It's from Mayor's Well Drilling.
Okay, well, listen, sorry you're late. Did you miss the password? Oh, no. Oh, no. In fact, I don't give that out till, probably halfway at the minimum, maybe 2/3 of the way through. So you're good to go. Never going to give those out too early on where somebody can just take it and leave, right? So you got to wait for it. Anyway, we're going to start off with the discharge up here at the top, all right? When we look at a discharge of a pump, just some of this is going to be very, very basic fundamental information, okay? But I'm not sure who I'm talking to today. There could be seasoned people out there, and there are people brand new to the industry. But you see these two little eyelets, two little eyelets on each side of this discharge. I don't talk about this very often, but, those probably aren't used very often either. Those eyelets are designed to hang this submersible pump on some kind of a safety rope, like a ski rope, a 1/4 inch or 3/8 inch nylon ski rope. You would hang that submersible pump on that. And, as I've traveled throughout this country, the discharge pipe that are going on submersible pumps vary from one geographic area to another. Some places they still hang these on galvanized steel. Some places they're hanging pumps on Schedule 80 or Schedule 120 PVC. Up here where we're located in Northeast Indiana, Northwest Ohio, it's not uncommon at all to hang a submersible pump on like this polyethylene coiled flexible tubing. Nonetheless, what you don't want is you don't want to lose a pump down in a well, right? So you don't want to take the risk of something coming off the discharge and you lose that pump. So these eyelets are just there for safety. It's pretty cheap insurance, but again, not always are those being used. But going back to the discharge, all right? There's two components in a discharge. And when I'm talking about discharges, at this point, I'm talking about anybody's submersible pump under any brand, all right? Two components. The first component that we're going to look at is what's called a check valve, all right, up here at the top. Right up here at the top is a I'll try to move that up and down for you. There's a check valve. I'm doing this blindly. There's a check valve up there, all right? That's a check valve. Now, I have a little concern about check valves. I'm just going to be straight up with you, all right? I sold submersible pumps many years ago, over 40 years ago, and I sold a lot of different brands. And I'm going to tell you something. Not one time ever did I have a failure of a check valve. It was unheard of. It was not even possible to have a submersible pump have a check valve failure back in the mid-70s. And again, I don't care what brand you might have sold back in those days, you were not going to have a check valve problem. And you want to know why? They didn't put a check valve in the pumps back in those days, all right? No, they did not put a check valve in the discharge of a submersible pump back in the day. It was up to you, the installer, to decide, whose brand of check valve are you going to use and where do you want to install it, all right? Somewhere in that water system, there needs to be a check valve. But back in those days, that would either be installed, on the discharge piping somewhere, up the discharge piping. I've seen them install check valves on tank tees that go right into the bottom side of a pressure tank, which is all way up above ground. Irrespective, you got to have a check valve in there somewhere. That's why we didn't have problems back in those days, because we as a pump company didn't provide check valves. Today, you can't buy a submersible pump that doesn't have a check valve in it. And I'm going to tell you something. Somewhere along the way, somebody got the idea that, okay, if every submersible pump needs, or every water system needs to have a check valve, hey, why don't we go ahead and just build one right into the discharge of the pump, all right? Now, if we do that, that could save that contractor, that installer, that could save him some time, him or her, that could save them money, right, by just putting it in the discharge of a submersible pump. So, kind of like sheep, that's what the industry did. And like I said just a few minutes ago, you cannot buy a submersible pump today, a typical 4-inch submersible pump, that does not have a check valve in the discharge, all right? That does not have a check valve in the discharge. Now, the high cap pumps, these high cap submersibles, These are rated at 35, 55, and 85 gallon a minute. A lot of these are used for irrigation. There's no check valve on these discharges of the high cap pump. That discharge is a 2-inch opening down there, all right? So you're looking right into the barrel of that, and you'll put a check valve on that system somewhere. But on these typical 4-inch everyday submersible pumps, there'll be a check valve at the top. I had an old boy that worked up here for a long time. He come out of Texas. I'm just going to give you a little check valve story here real quick before we continue on, but he worked out of Texas, and he said to me one day, he goes, Dan, my name Dan has 2 syllables in Texas. Dan? He goes, I'll tell you something. The best check valve Flint Walling ever had was that old silver dollar. They used to put an old, like it looked like a silver dollar they used to put in that discharge of that pump. He said, man, I'm going to tell you something. We never had any problems with that. Never had any problems with that. He goes, but I don't know, at some point they got rid of it, and I'm not really sure why. Maybe it just cost a little too much money. I don't know. But that all said, Flint Walling has come full circle. And this check valve that is in the discharge of our Commander stainless steel submersible pumps is reverting back to what this guy had told me earlier, many years ago, kind of that old silver dollar type of check valve. It's basically just got a poppet. I'm going to try to show this. It's just got a poppet that floats up and down. I don't know if you can see this closely, but the bottom side of this poppet, I'm going to try to hold this up, has a clear boot on the bottom side of it. This one is clear, and it's only clear so we can show customers how we engage that rubber poppet onto this metal stainless steel silver dollar piece. It engages into some slots on the back side of that. It's not very easy to see here on the camera. But that would normally be all black in reality, just like you see up here. That would be all black in reality. That's the check valve. And I'm going to tell you something. Since Flint Walling went to that check valve, I don't hear anything about them anymore. But I'm going to tell you something. When it comes to these check valves, all right, I've always had a little bit of heartburn over these check valves, and it's not the fact of having one, it's where it's located. I'm going to advance to a slide here real quick, see if this will move forward for me. Okay. All right, I'm going to move. If you ever saw the water,
Dan, you might have to pause. You just lost your sound.
Oh, no sound. Okay. Are we back?
But it's away, so I can't tell on here yet.
if you can hear me, sorry for the technical. We'll be back online here shortly as soon as I get the cue from the team.
There you go. I can hear you. You might want to roll back and repeat what you were saying.
Roll back
and.
All right. Okay. So I guess we're back online again. The reason you've got the industry's, pretty much the industry's check valves over there on the right-hand side. But the reason I'm, not a big fan of check valves that were put in the discharges of pumps. Now, like I said, the one that we have now today has alleviated this concern. But here's the concern I had. I'm trying to advance this slide. There we go. If you ever saw the water as it's leaving the discharge of this pump, That water isn't coming out of there straight like it comes out your kitchen faucet. Oh no. That water's spinning at about the rate the motor's turning, all right? So that's a very, very turbulent atmosphere in that discharge. And so, you know, these pump companies are trying to get rubber O-rings and rubber gaskets and everything else to try to seal every single time that pump cycles in that atmosphere. Good luck. Good luck. I'm going to tell you something. Everybody that puts a check valve in a discharge of a pump will, not maybe, will have an occasional failure. Some a lot worse than others, but there will be failures just because of the location and the turbulence of that water moving through that discharge at that moment in time. That water doesn't even start to straighten up until it gets, you know, probably 6, 8, 9, 10 feet up that discharge pipe. Then that water will start to straighten up a little bit. That's why when you have a check valve in line up the discharge pipe or up at the tank T or wherever you may put it between the pump and the pressure tank, they'll work all the time, right? Because they're not seeing that turbulent water coming out of there like the discharge in a submersible pump. Anyway, enough on the check valve. The other component that's going to be in a discharge is what's called a discharge bearing, all right? Now, you can see in the bottom of this discharge, I'm pointing right there, that's that bronze. Flint Walling uses a bronze, no lead, closed, keyword, discharge bearing. Here it is right here, all right? It's a bronze closed discharge bearing. It sits right over the top of the shaft just like that. It's closed on top. Now, if you are not using a closed bearing, all right, if you're not using a closed bearing, then the only other choice really is some type of a sleeve bearing, all right, where the pump shaft would actually go through the inside of a sleeve bearing. All right, I'm going to show you a picture here in a minute or two, but let me just talk about this for a second. And the reason that we use the closed bearing and the reason that we make it out of a no-lead bronze. I'm going to show you here in a minute why that is. But, you know, over the last, 40 years or so, I've had really, it's been a privilege to travel this country, all on business, but I've been to almost every state. And I'm going to tell you something. In my opinion, there are a couple of states, I'm not going to name them, but there are a couple of states that I don't care where you drill a well, all right? You're going to have sand. Not maybe. You're going to have sand. And I've made that comment many, many, many times. And actually, I've made that comment in those states that are, you know, the states that have that sand-bearing water supply. I had a contractor one time look at me. He said, man, I don't appreciate that. I said, you don't appreciate what? He said, well, you just said that every well drilled here in this state has sand. I said, well, it does. He goes, no, not mine. I go, well, what are you doing that nobody else is that your wells don't have sand? He said, man, I screen my wells, don't you know? He said, I screen those wells off. He said, I know what you're talking about. He said, but that's not a problem I'm having. He said, I screen my wells off so I don't have that sand problem. Well, I'm out on a job site one day with this guy. And, you know, he's developing a well, and I'm sitting in the back of the house with him, and I had to use the bathroom, so I walked in the back door of the house, and inside that back door was the half bath. I used that bathroom, and while I'm in there, I took the flush tank lid off the flush tank, and I looked down in there, and guess what I saw? Oh, yeah, I saw probably a good inch, if not more, of sand built up in the bottom, laying in the bottom of that flush tank. And so I opened that back door up, and I said, hey, Mr. No Sand, hey, come here a minute. The guy walks up. He goes, what? I said, look in there. I look in that flush tank. I go, where do you think that came from? He goes, man, he said, that's sugar sand. That doesn't count. And I go, what do you mean that doesn't count? He goes, that stuff's low. He goes, look how fine it is. He goes, it's really, really fine. It doesn't plug the aerators up in the kitchen faucets. He says, yeah, every well's got that. Yeah. All right. If you've got a sleeve bearing, all right, and you're using a sleeve bearing, which every pump company uses, our team here, our engineering team at Flint Walling, they do not believe that sleeve bearing is a watertight fit against that pump shaft. It's not a watertight fit. We believe water can and will pass by that bearing, all right, or through that bearing, between that shaft and between that bearing. And listen. Oh, that doesn't count. That sand's really, really fine. Oh, yeah, I know. So fine that it could possibly get between that sleeve and that bearing? Because if you're starting to run that kind of water through a pump that's got a sleeve bearing on it, and you're running that garbage up between that bearing and that pump shaft, and you prematurely wear that bearing out, you just lost that pump, and not maybe. That's the only bearing in the pump side of this thing, is that discharge bearing. It's a very key and critical component, all right? I'm going to pull a slide up here again, Renee, because I want to show you why we use the closed bearing in our pump ends, all right? So, all right, there's our closed bearing, as you can see. Now, again, that's a no-lead bronze bearing. But here's what I'm talking about when I'm talking about a sleeve bearing. And here's also what I'm talking about when I'm talking about that fine sand, all right? Equate it to these snow globes. Kids love these little things. They're like souvenirs, you know? You go out and you shake that rascal up and you set it on a table, and for the next, 30 seconds or so, you can watch all those little fine sprinkly things slowly settle to the bottom. If you have a sand-bearing water supply, when that pump shuts off, that same thing takes place. Any sand that's in that water, when that pump is shut off and the system is idle, is slowly going to settle its way back down. Now, if that sand is so small, and we know that water can pass up between that bearing and that shaft, and you start running sand up there, you know what happens, right? You prematurely wear that bearing out. That does not happen with a closed bearing. There's no place for it to go. So there's no path, no water path through that bearing. So I think you can grasp that it's a dead end. It can't go through there. So we're not running garbage and sediment and abrasives along that pump shaft up there. Here's your industry. All right, again, we don't take these pumps apart anymore. So how do we know what kind of components are going into these things? Well, there's pretty much, these are all popular brands. It doesn't matter whose they are, but you know, not all these pumps are created equally. I'm just going to point that out. Now, let's look at these, what can happen, all right? So let's suppose you get under a heat rise condition. You got a pump that's run dry. You've got a pump that's deadheading. It's pumping against a closed valve, and it's simply churning that same water over and over and over again. You're going to create a lot of heat rise, right? So let's look at what happens when we do destructive tests in-house, and we do a lot of these. We want to do comparisons to see how does our pump compare with our peer group in certain destructive tests. So let's look at a heat rise condition. This bearing didn't last an hour. In fact, it barely lasted 45 minutes. It's a closed bearing, as you can see, but it's made out of plastic. And plastic is not going to take heat, right? So plastic's not going to take heat. But again, the concept of closing that bearing off was good, but making it out of plastic, when you get into a heat rise situation, not so good. And here's that other bearing. Now, that bearing is very, very pliable there. You can squeeze that bearing between your index finger and thumb. It's a very pliable sleeve bearing. But again, you can see what happened in the situation with a heat rise. Neither of these components are designed to take any type of heat at all right? Well, there's that third bearing down there. This is a ceramic bearing. I'll tell you, they brag about this a lot, all right? And rightfully so. I mean, the people that use these ceramic bearings in their discharges would tell you, man, I'm going to tell you, ceramic's been around a long time. It is a very hard surface. It is a very smooth surface, and it is an extremely good sealing surface. Yes, yes, and yes. They're right. But keep this in mind. Ceramic does not like temperature change. When you get a temperature change and you've got a ceramic bearing, that bearing's going to crack. You're going to get a hairline crack or a fracture down through the side of that bearing. And when that happens, you just lost that bearing, all right? So again, when you get into heat rise situations, which typically you and I don't have any control over, look at this. 4 hours, run dry. 4 hour, run dry. By the way, that second bearing almost made it an hour. It made it 54 minutes. The first one was almost 45 minutes. The second was almost an hour, but here is a Flint Walling. And this is after a 4 hour run dry. So that's why we use a closed bronze discharge bearing, so that we're not prematurely destroying our pump shaft, and we don't want this system to go down in the situation that we get into with a heat rise. So that's all in the discharge side of the pump. And so with that, now we're going to move down into the stack, all right? Are we doing on time? All right, we're all right. All right, so this is a typical Flint Walling impeller. And I just want to point a couple things out. Typical Flint Walling impeller. First of all, this is the eye of the impeller right here. It's got a large eye on it. You can see it. I'm trying to shine that in the light. You can see that large eye, all right? And then this side is the hub. I'm going to hold that. Yeah, there. That's the hub, okay? So you've got the eye, and then you've got the hub. If you look at a Flint Walling impeller, and this is not uncommon at all, the top segment of this impeller right here that's on the hub side is slightly smaller in diameter than the bottom side, the bottom segment, all right? It's slightly smaller in diameter. In fact, you can see the veins. I'm going to try to show this. You can see the veins actually sticking out the ends of this impeller right there, all right? Some contractors, they call this a loose stack. That's what they call it. And the reason they call it a loose stack is that the tolerances in a Flint Walling submersible pump are not very tight. We do not want tight tolerances. Tight tolerances leads to a lot of problems when you have sand-bearing water supplies. You're going to sand lock the pump bigger than big. So we do not have real tight tolerances within our pump. All right, now, this is what's called a thrust washer. Let's see, I think I've got, well, now, before I get to that section, let's talk about another destructive test here that we did, all right, sand. I don't know if you can see that slide up on your screen, but the image that's being shown in the center, that's another brand of pump. It doesn't matter whose brand, but the tolerances are very, very tight on their impeller. It's very tight. And so when you start to introduce sand into that pump end, there's no place for it to go. All it can do is erode material off of the impeller, which is what it's doing. It's literally eroding material off of that impeller. And I'm going to tell you something. When that test was completed, there was no performance left. That pump did not have any performance left. These two guys over on the right-hand side, I don't know, it almost looked like they were in the mirror looking at each other when they designed these. They're called non-clog impellers. That's what they call them. But yet you can see in a situation where sand is involved, it didn't fare much better than the first impeller that we showed you. You can see the rings going around that impeller where that sand's eroding that impeller away. And again, after that test was completed, there was no performance left, none. Here is a Flint Walling impeller. Move my head out of the way. Maybe you can see that little bit of rub, just a slight bit of rub around the eye. That's it. No grooves, no wear, just that little bit of slight rub. And again, that's in exactly the same test protocol that the other impellers were in. And the post-test on that pump was identical to the pre-test pump curve. So there was no damage done to that impeller whatsoever that changed the integrity of it. All right, so now when we look at the rest of this impeller, this is what's called a thrust washer. Some people call it a thrust bearing. Flint Walling manufactures these out of stainless steel right here in our factory. But that thrust washer sits right down over the hub of that impeller. And the reason that this thrust washer is there, and it's in all submersible pumps, they'll all have some type of a thrust bearing or a thrust washer. But the reason that it's there is to compensate for a condition referred to as upthrust. Upthrust, all right? And some of you have heard that term before. If you haven't heard that term and you're around the industry for any length of time, you probably will. And let me explain to you what upthrust is, so when you hear it, you'll know it, all right? Upthrust, by definition, is a sudden and forceful upward movement, all right? That is the definition of upthrust. Well, let's look at that, let's look at that word sudden, all right? Let's look at that word sudden. That motor that's on the bottom of that submersible pump is going to come up to full RPMs in the blink of an eye. 0.4 of a second, that motor is going to go from 0 to 3,400 RPM in 0.4 of a second. That's pretty sudden. When you set a pump down in a well for the first time, whether it's a new installation or whether you're just simply replacing a pump. Understand that everything in that drop pipe above the static water level is empty. There's no water in that drop pipe above the static water level in the well. There's no water in that drop pipe. There's no water in that tank that's up above somewhere. And so when that pump first comes on, it wants all those impellers and diffusers. I'm going to show you all this. All those impellers, they want to come right out the discharge of that pump right along with the water. That's what's called upthrust, because there's no head pressure. The pipe's empty, the tank's empty. That's throwing water up there in an effort to fill that tank and pressurize that system as quickly as it can. And during that initial time, that pump's in upthrust. All pumps will be in upthrust. That's why we use stainless steel. We don't know how long we're going to be in that condition. I've seen contractors, when they develop a well, they'll throw a pump down in a newly drilled well, and they'll pump that thing open discharge right out over the grass until the water clears up. And sometimes that takes I've seen it last for a couple of hours, where they're pumping that well open discharge to clear all that drilling fluid and all that mud and all that stuff out of there before they hook it up to the system and run it into the house. They're running it out over the grass for 2 hours. And for 2 hours, they were in upthrust. And here's these pumps are not all the same. Nobody takes these pumps apart anymore, so who knows what kind of components are being used inside of submersible pumps today. I'm here to show you some of them, some of the components, and where some of the differences are. But that's what the thrust bearing's for. Before we go into the staging, let me describe. I'm going to not use slides here for a second, Renee. But I want to show you what happens here, and I hope I can demonstrate this live for you. Okay. So again, this is our impeller, the hub, and the eye. That eye is big, and it's got a big ridge around it. All right, big ridge around that eye. It's kind of there. You can see that ridge right there around that eye. All right, so what I'm going to do is I'm going to put a thrust washer over the top of that hub. This impeller now sits inside of what's referred to as a diffuser. All right? Excuse me. Every impeller is going to have a diffuser. In classroom, I would tell contractors that for every impeller that you add to a pump, all right, I don't care if it's a jet pump, a centrifugal pump, or a submersible pump. For every impeller that is added to that pump, the end result is that pump will produce more pressure. More pressure. That's why some of our deep set submersible pumps, they may have 40, 50 impellers in it, because they're going down a well that's 800, 900 feet deep, and you got to have a lot of pressure just to bring that water up to the surface. So I tell everybody, by adding impellers, you add pressure. That's half true. When that water comes into the eye of this impeller, all right, when it comes into the eye of this impeller, understand that this impeller is spinning at the rate the motor's turning. So it's spinning at 3450 RPM, and that water coming out those eyes of these impeller is coming out under an unbelievable velocity. That's what's happening there. That water's coming out under a huge amount of velocity, but all that velocity is being captured inside of this diffuser, just like that. So if you want to know what a diffuser does, I don't care, again, whether it's a jet pump, a centrifugal pump, or a submersible pump. What a diffuser will do, its sole purpose is to take that velocity that was created by that impeller and convert that velocity into pressure. So therefore, every impeller is going to have a diffuser, so every impeller is also going to increase the amount of pressure. All right? So that impeller just sits down into that diffuser plate. I'm going to... looking at the here, just like that. Now, this is the diffuser plate. It also has a large ridge on it. All right, that goes on to this. So this is a stage. This becomes a stage. So it's basically the impeller, the thrust washer, the diffuser, and the diffuser plate. They all sandwich together and they become a stage. And I want to tell you something. And I don't know. I've heard other pump companies stake this same claim. I don't know if it's true or not, but here's your fact and fiction stuff. You know, when people, if I had $1 for every time somebody came up to me over the course of my career and said, hey, those F&W pumps, I'll tell you one thing, I don't have to work on them very often. They last a long time. Well, that's all true. And a lot of contractors know that. But what they don't know is, why is that? Well, I'm trying to point some of that out with the closed bearing at the top, the new check valve, and the way that this stage is designed. Flint Walling manufactures what we call a floating stack. A floating stack. And I want to demonstrate what that means. When this impeller goes inside of this diffuser, and that large ridge on the eye of that impeller sits inside the large ridge that's on this diffuser plate, like that, that impeller has the ability to float. I'm going to try to move it that impeller has the ability to float up and down inside that diffuser. You can see that movement right there, That's what's called a floating stack. And let me explain what that really means. When we build these pumps back there in our factory, and we build them like we're supposed to, we build them correctly. When that pump is up and running and under a load, all right, key word, up and running and under a load, that impeller is designed to float in the middle of that diffuser. So there is no rub at the bottom, there is no rub at the top. It is literally floating in that diffuser. And when you accomplish that, think of this. If you're floating an impeller inside of the diffuser, where's the wear going to be? Where is all that wear going to be? Well, it doesn't exist. Again, because there's no contact between two materials. It's just floating inside that diffuser. And when I say when we build these right, we do a lot of testing as we're building these pumps. And what we find is that periodically we need to put a thin shim on the top of this hub, so that as we build this stack up, you know, we have all these impellers in here, that they're all lined up so that they are literally floating under a load. All right. The last thing I want to talk about when we talk about this pump in, and I'm going to go to a slide now again, Renee, real quick, is the staging. Flint Walling has never destaged their pumps. If you destage a pump, you're taking impellers out of it, and that has been done in this industry. There has been some destaging take place. Don't think it hasn't. Well, who benefits from that? I don't know that it's you or I or the customer. But Flint Walling has never destaged their pumps. When you destage a pump, I assume you're taking cost out. And I don't know if that's a good thing or bad. It's a good thing if you're a publicly traded company, I suppose, and you got stockholders and shareholders. But we've never destaged our pumps. And here's what I want to show you. This is a typical, hey, here's your code word for the day. Curve. Curve. C-U-R-V-E. There's your code word. This is a typical pump curve, all right? And if you look at those black dots, and I in other sessions of the House of Resistance on subs, I actually go through and show people how to read a pump curve. But those black dots indicate the sweet spot, all right? Indicate the sweet spot on that pump curve. When you go left, if you find yourself having to go left of that curve, and that happens a lot, we underestimated the total amount of feet of head that we had, or the total depth that we're setting the pump, and we end up with more feet than what we initially thought. And you find yourself moving to the left-hand side of those sweet spots. Flint and Walling pumps are still going to give your customer water, where other pumps, they'll flatten out real quick after that sweet spot because they don't have the impellers in there to handle the additional depth and feet of head. All right, that's what destaging will do. It gets you this, gets you the sweet spot, and then it stops. It stops right there. That's a Flint and Walling submersible pump end. We don't make these materials out of the same. All right, we differentiate the plastic components inside so that when we do get in heat rise conditions, these things don't just start melting down right on top of one another. I also want to mention that there is a publication available. It's this one right here, and its form number is an FW 2078. It's a brochure that's entitled "Why Buy F&W." But what I want to point out is inside this brochure is everything we just talked about today. All right, starting up with the discharge bearing and the check valve, down through the stack, into the components of the impeller itself. So those are all available. Anyway, I hope that this gave you a little more insight about what goes into a submersible pump end. Again, pointing out some of the differences that we do here at Flint Walling, I think is what makes our pumps last so long. One of these sessions coming up, we're going to do the bottom half of this. We're going to talk about the motor, so stay tuned. Hit that like button, or certainly hit that subscribe button or notification so you know when that's coming, but that's going to be coming up shortly. I also want to point out that in some upcoming live streams, we're going to be talking about the new Commander 2 and 3 variable frequency drives. I'll have some guests in here helping me with this one. And in fact, we'll probably have some guests in upcoming live streams that will kind of shake things up a little bit. But don't miss this one. This is something that I think if you're into the variable frequency drives, you're going to want to know about this. It's very sellable and very, very affordable, and it's got the features that you need. So anyway, don't miss out on that. Short of that, I think that's pretty much come to the conclusion here. I was hoping that maybe we could make this last half hour, so I think we accomplished that. Anyway, I appreciate everybody being with us. Email that code word CURVE into marketing@flintandwalling.com, along with a couple other code words that we're going to be giving out in the future, and you'll get that surprise gift that's up and coming. By the way, this code word thing, we're going to end that at the end of September, once these morning broadcasts conclude, and then we'll probably switch to factory tour seasons. These factory tours are very, very popular during the fall, winter months. If you have a chance, I'm going to tell you something. If you have a chance to come back to our factory for a factory tour, I personally will walk you through that factory, and I guarantee you, you will have an experience that you can't get at any other pump company. With that, have a great rest of your week, and I'm going to close this one off for now. I appreciate the back help with Derek and Renee, and hopefully these things will get smoother as we go, and talk to you the next time. Sip that ground coffee.